Welcome back, Physics 30. So we did this example here, analyzing the situation vertically. Let's look at the part D. Your friend pulls upwards this time with 40. What is going to be the normal force now? So again, we'll draw a free body diagram. So there's the ground or table. Here's the object we're talking about. Here's FG, doesn't change. All right, so this time we have a force, the FP or the F pushing or pulling force is going to be directed upwards, and that's going to be 40. And as you can see here, so that's going to be easing up on the force required by the table to counterbalance what's happening with the gravity. So you can see Fn is going to be much less than Fg. Okay, so if I didn't have this force, Fn equals Fg. But when I have these extra forces being applied, it's going to change how much of a normal force I actually require. So again, we'll analyze this vertically. So all the forces that are involved are Fg, Fp, and Fn. And again, this object is just sitting there, right? So of course, F net is going to be 0. And our Fg is still negative 98. That's not going to change. Ooh, my 9 got kind of weird there. And the pulling force, now it's being upwards this time. It's an amount of 40, so I'm going to put it as a positive 40 because it's upwards. And then we'll be looking at Fn, so negative 98, and a positive 40, and a positive Fn should give me the result that I need. Negative 98 plus 40 is negative 58. And then add 58, and oh, and look what happens here. The normal force is simply plus 58 newtons. So of course my gravity is negative 98, my gravitational force. So you can see I don't need a positive 98 because I have this force here, also directed in the same direction, and I don't need as much normal force to counterbalance the weight to keep it motionless on the table. So that's how we handle that. All right, so if we look at the next page, let's take a look at something else here. What happens when a person pulls upwards? So a person's going to pull upwards on the box from the previous question with the force equal to or greater than the box weight. For example, if Fp is 100 rather than the F equals 40 newtons, what happens? And then so you should likely draw a diagram first. It's going to be very similar to the previous diagram, right? So we'll draw the ground or the table. Fg is pulling downwards, and we have our pulling force in this direction. The length of the arrows, I don't need to worry about that just yet. Then of course we have our normal force. So let's analyze this again vertically. Okay. So of course we have the overall vector resultant force, or F net, is equal to Fg plus Fp plus Fn. So all the forces I have being acted on there. And of course, yes, it's not moving as far as we know, 0. My gravity is this. My pulling force upwards is plus 100. So what we have happening here is we have plus 2, just to put a direction on there. And then minus 2, minus 2. I guess there's just one less 0 there, right? And, oh, you run into a weird scenario that Fn is negative. But as we can see, no, it's pushing upwards. It's positive. So we need to make a little note here. So Fn cannot, I got a little messy there, cannot be negative since it must be directed upwards at all times. So what must be happening here? So if our gravity is negative 98, and if I'm pulling up at 100, Oh, we can see here that my pulling force upwards is greater than the weight. So of course, so wait a second. So what that means is box must be accelerating upwards. And therefore Fn must be equal to 0. So what's happening there is that I don't need a support force, because guess what? My upward force is pulling more than my gravitational force, so the table won't be pushing up on it. So it'll be a case in which, if I was to think of it like this, so I have my Fg pulling downwards, and I have my Fp. So notice I draw it a little bit larger here. So this Fg force may take up, counterbalance this much, and then I'm going to have just a small F net force pulling up overall, because Fg will cancel with some of this. Oh, sorry, this is Fp, not Fg. There we go. So Fg will cancel with some of the Fp, and then I'll be left with a certain amount of force left over. So this is how we have to analyze it vertically. So F net is equal to Fg plus Fp. Now if I include the Fn, I know that, yes, it's not going to exist because my Fp is so much bigger. And this is going to result in a net force here, right? It's negative 98 plus a plus 100. So this is equal to negative 98 plus 100. So of course that's going to equal plus 2. So I do have a net force. And of course, if I have a force that's not counterbalanced, that means there will be acceleration. So if I have a net force, that means I have acceleration. So 2.0. Now this is a 10 kilogram mass that we had, that we were told earlier. So divide by 10, divide by 10. So my acceleration is going to be 0.20 meters per second. And as a direction here, I could put plus, or maybe even better might be to say there's going to be 0.20 meters per second squared upwards as a net force. So that's what happens when our upward force is more than the gravitational force. Okay, if you look at the next page, I have an elevator question here. But what I'm going to do is I'm going to save that for FI1, the gravitational field section. So we're going to leave this, and then we'll tackle that later on when we do the gravitational field section. All right? But what I would like to do is maybe to talk a bit about the FM2.6 assignment and maybe give you some hints with that. Okay, so when you look at number 1, it's talking about a cable using to accelerate a car upwards. So to draw that free body diagram, we don't have it sitting on the ground. It's being accelerated. We know it's going to be moving upwards like this. So we know that there's going to be an overall resulting force upwards. So we have Fg pulling downwards, and it talks about tension force. So I'm going to call it Ft. So as you can see, I purposely drew it larger than this because there will be an overall resulting force. And then of course, once we have F net, we'll be able to figure out A. So again, analyze this vertically. So vertically, we have F net is equal to my Fg plus your Ft. So you'll have to figure out this first, because I think the object is 1,200 kgs. It's a car. So of course, yes, figure out the force of gravity, and then we'll be able to analyze it like this, and then move from there. Okay, question number 2. It's a situation that looks like this. We have a couple of boxes, so it tells you to analyze this first of all. If you have a 20 kg box, you should be able to figure out what Fg is, then from there figure out what Fn is, and of course the box is motionless on the tabletop. So you should be able to figure that out quite easily. And then B, the scenario becomes, okay, so we have a 20 kg box. And on top we have a 10 kg box. All right. All right, so the first part, excuse me, so it says determine the normal force that the table exerts on the 20 kg box. So you can think of this whole thing as being one big object. Okay, so 20 plus 10 is a 30 kg box. So analyze it like that by figuring out the FG, and then analyzing what's going on vertically. So of course, F net is equal to FG plus Fn. And then the scenario becomes, okay, well, what's going on with just the 10 kg box? So then you could think of it, okay, let's look at the force of gravity just on the 10. So in that case, the 20 kg box kind of behaves like a tabletop. And you should be able to figure that out. And then the last question, number 3, is very similar to number 1. You have a 14 kg bucket. So if you know the mass, you should be able to figure out Fg. And it said it's being lowered where there's a tension force. And they give you the tension force. It's 163 newtons. That's directed upwards. And just to give you a hint, they're not going to balance each other out. So vertically, we will have one of these forces will be larger than each other. So either Fg will be bigger than Ft, or vice versa. There will be a net force. Then from there, you'll be able to figure out what the acceleration is. All right, so those are some hints with the assignment. You should be able to do them no problem, and we'll see you again.